Well, the following question says, prove that QBSP is a parallelogram. All right. Basically, we are asked to prove that this shape here, okay, so this one I'm going to draw in yellow, or maybe let me change the color, let's say purple here, this one, that one. So we are asked to calculate this, that this, and that one is a parallelogram. So how can you do that? There are many ways to prove that a shape is a parallelogram. Okay, I'm going for the properties of parallelogram first. Let me write the question here. 3.6. 3.6. We are asked to prove that QBSP is that is a parallelogram. A parallelogram. There are conditions for parallelograms. Okay. The first condition when I use here is when the midpoints of the diameters are common. Okay, so one condition will be when the midpoints here. So if I take this one and that one, okay, they all have same midpoint. Okay, so this is one of the proof. Okay, I'm going with that. I want to say okay, let me first take the same graph so I cannot just move it over all the time. I want to take the graph of the equation. I want to take it. Okay, I want to paste the same graph here. So we need to prove that the graph in purple here is a parallelogram. So I said first we prove with the midpoint. I want to check the midpoint. It's condition one will be the midpoint of PB must be equal to the midpoint of do not confuse with the gradient. Midpoint is a point, so we capital letter here, and then must be equal to the midpoint of QS. Now let's find the midpoint. So the midpoint PB will be the midpoint first is given by x1 plus x2 over 2 and y1 plus y2 over just the average. Okay, so midpoint PB will be then 13 plus we did find the value of B in the previous question. B was found to be equal to 3 over 2. So it was the x value, the x coordinates was 3 over 2. On the sub here, B there was 3 over 2. Let's just place an arrow there. It was 3 over 2. Now when I sub in, I want to do 5 plus 3 over 2 all over 2, and then the y coordinate will be 13 plus 0 because it is the y-intercept, the x-intercept over 2. Now this must be the same if it is a parallelogram. Okay, because we cannot just say it is a parallel because it looks like a parallelogram. We say it's a parallel until we prove it is a parallelogram. So now we're going to check if this is equal to the midpoint of that was the midpoint PB. That's why PB. Now another proof is the same as the midpoint of QS. So I'm gonna use X1 7.5, so 7.5 plus minus 1, so minus 1 over 2, and then 8 plus 5 over 2. Let's check. This will be midpoint PB will be 5 plus 3 over 2. If we use the calculator here, this is going to be 10, 13, that makes 13 over 4. Okay, if you look at that's going to be 13 over 4. And this is going to be 13 over 2. 13 over 2. And then the midpoint QS will be 7.5 minus 1 is 6.5. And 6.5 is over 2 is 13 over 4. And then 8 plus 5 is 13 over 2. Now we can see that the midpoints are the same. So you see the exponents are the same. So therefore we can say, therefore, QBSP is a parallelogram. Is a parallelogram. This is one way of solving this. The other way, the gradient, okay? If I can prove, because parallelogram means the lines are parallel, we have two pairs of parallel lines. It means that this line will be parallel to that one, this line is parallel to that other line, meaning the gradients, these two gradients here, the gradient of this line and that line must be equal. The gradient of this one and that one are equal. We already have one gradient. We work out already the gradients of QS. So we already know this was a 4 over 3. Then check the previous work. When we work at the gradients, it was 4 over 3 there. We can see it there, or we can also see by here the gradients of QS 4 over 3. Now, so when I say here the gradient is 4 over 3. So now we need to prove that this one is also 4 over 3. And then we need to find this gradient. We find that gradient. Okay, if this is 4 over 3, that also 4 over 3, then it is a parallelogram. Let's see. Let's find the gradients of QP or PQ. Same. You can work out the gradient PQ. We say MPQ will be, let's look at, they are like, I want to say 13 over 5. No, 13 minus 5 over 5 minus 1. So that makes 13 minus 5 over 5 minus 1. And then this makes that MPQ equal to 8 over 6, which is MPQ equal to 4 over 3. Now we say this part we already sorted, okay, because here is also there is also 4 over 3. So I say that 4 over 3. We can also look if to prove that these gradients are also equal, okay? If I want to work out the gradient of PS, it's let me can just copy this again, or maybe I want to redraw the same graph here so we don't move around all the time. Move the thing all the time. Let's see. PS will be what? Dy 13 minus 8 over the x, I want to say 5 minus 7.5. Okay, this will be 13 minus 8 is 5, and 5 minus 7.5 is negative 2.5. and then this is equal to -2. So this gradient here is -2. Now let's find if this gradient is also -2. I'm going to work out the gradients of QB or BQ. BQ. This will be B. The x value of B, we said it was 3/2, right? And now the y value is 0 because it is a y-intercept. It is an x-intercept. So now we're going to have 0 minus 5 all over 3/2 minus 1. So that makes -5 over 3/2 plus 1 will make 5/2. And if you do this calculation, you get -2 again. So here is also -2. Therefore, we say QBS P is a parallelogram. We can also find the parallelogram by working out the distances of all these sides, okay, and then check if they're equal. If the distances are equal, then meaning I'm saying this distance, the distance QP is equal to the distance SQ, SB, or QB equals to PS, then it is a parallelogram. You can do it. You can do it also. Let's just. Split it. We see doing 3.6. We can do prove that if the distance, I want to say PB, the distance PQ equal to BS and BQ equal PS. Now let's prove. Let's work out PQ and BS. We already worked out the distance PQ. We found it in the previous question. We found that PQ was equal to 10 units. Okay, that was given already. Now we can work out BS also. This will be square root of x2 minus x1, so 7.5 minus x1, which is 3.2 to the power of 2 minus plus 8 minus 0, okay, to the power of 2. Now this will be, if we work it out, this will be, if you press this in the calculator, I can see the answer. It will be 100 here. This is 10 units. Okay. Same also with BQ. We're going to do BQ. B is 3/2. So I'm going to do -1 minus 3/2. Excuse me, to the power of 2 plus 5 minus 0 to the power of 2. Doing this in the calculator, we also get, this would be BQB. I'll type in the calculator quickly. That makes 125/2. Okay, which can be written as because it's going to be like square root of 125 over over 4, so over 2. Or I can just do we can break it like that, and then this is like 5√5/2. That's BQ. And let's see PS. PS will be square root of 5 minus 7.5 to the power of 2 plus 13 minus 8 to to the power of 2. Okay, and this also gives square root of 125/4, and which is 5√5/2. In conclusion, this is also a parallelogram. Thank you.